Okay, welcome back to BME 2315. Today we're going to look at a few more details of Python programming, particularly how to deal with arrays and how to start plotting our variables. So as a reminder, in Spider, our working directory is defined up here, and that's where I've saved my files. So I opened that up already. This one is called Python Basics 2, so that you can look at it yourself. The first thing that we're going to do is be importing this NumPy library. So it's called NumPy, and we import it using this command. And basically what NumPy does is it provides numerical arrays, sort of data types that are very useful for numerical computing with precision and speed. And so it also provides a variety of functions to deal with those. So we're going to start by doing this. I'm just going to copy that to my console so that I'm showing one thing at a time. And note when I show NP, that's showing in memory, it's got a module called NumPy loaded that we can access. So the first thing that we're going to do is define a simple array. We're going to define an array A, like this. And we can see it in the command line, or we can go to Spider's very nice variable explorer and see that it's listed right here, that it's an array of 32-bit integer with a length of 6, and it's 1 through 1, 2, 3, 4, 5, skips 6, and then 7. Okay, and we can verify that the data type by saying a.d type right here. So it tells us it's a 32-bit integer. And then we can do some basic array indexing. So for example, if I want 0 to the second, and remember that in Python, it's going to include this first one and not include the second or last one. So it's not inclusive of the end. And so that's why when we do this slicing, that we get 1 and 2 as the output, or whereas if we do 0 to 3, we get 1, 2, 3. So it's not including the last element that was stated there. And we can also do things like look at the shape of a.shape is 6, so it's only kind of 6 elements, but there's only a one-dimensional vector. So let's look at something that's not a one-dimensional vector, this matrix B. So again, we can see it here, or we can look at it in a variable explorer, like that, or you can click here and you see in a spreadsheet type form, you can see the entire array in this way. And it has nice highlighting showing the values that are much higher or lower than others. So if we go back to the console, we can look at a couple things that we can do with that. We can look at its shape, and for example, we can save the numbers of rows and columns like this. So now we can see that number of rows was 3, and number of columns was 2. And you can reference specific values. So say if we want the 2, 0 element, then its value is 3. Or if we want the entire second column, then we do colon, that means all of, and then 1, because remember the indexing starts with 0, so 1 is the second column. So this tells us that 418 is the second column of matrix B. So finally, we can create a third array that's a two-dimensional array or matrix like this. And again, if we look at the variable explorer, it has a nice color coding kind of to help us see or verify that those values are what they're supposed to be. Okay, so we went through both defining these variables and indexing on those variables. The next thing that we'll do is looking at how you can plot within Python, and we're going to be using the matplotlib library. And so Matplotlib is really nice because it makes plotting very accessible and uses a MATLAB-like context. So as I show you, I import this package here called import Matplotlib. Let's now create our independent variable x, and so we can, if we look that up in the variable explorer, we can see that that starts from a low value and then continually increases to a high value of almost 10. Let's now define a variable y that uses a sine wave and an exponential multiplied together. And so if we look at that in the variable explorer, we see that it's increasing, but then it's also kind of oscillating a bit. So it has some interesting changes in its values. So finally, let's just run this whole thing. If I hit this button right here, it's going to run everything in the current cell. And you can see that it plotted our function for us. So we have x and y, and we have this oscillating sine wave. So I hope that was helpful for you, and good luck with Python.